Welcome back, everyone. Today is day 2 of the Advanced Robotics Summer Camp, and today we're going to be focusing on CAD Design. Previously, we went over game strategy, and the game we're going to be focusing on is Keystone. As made evident by the previous video, scoring stones is vital to being successful in this game. Today, we're going to be going over an intro to CAD, or computer-aided design. We'll be introducing Inventor, the most commonly used program for CADing. We'll be covering how to get parts for constructing things in CAD. And then finally, we'll be making a drivetrain and grabber in CAD, and we'll go over different features used to create these parts. CAD stands for Computer-Aided Design, and like the name suggests, it is the process of designing the robot in a computer program. Although this is typically what a lot of teams do, there are teams who prefer to prototype first and then CAD the working result as documentation. A good example of this is Masquerade, because they prefer to prototype first, as it allows them to iterate quickly and effectively. There isn't a right or wrong, it's just a matter of what works best for the team. In CAD, the goal is to put together a design that can complete as many game tasks as possible. Some teams decide to import COT parts, commercial off-the-shelf parts, and build an assembly with that, while other teams decide to go completely custom. Again, neither one is objectively right or wrong. It's just a matter of the team's available resources and preference. Usually, teams decide to CAD for one of two reasons. Either they decide to CAD for planning purposes, like 3846 Maelstrom, or they decide to do it for documentation purposes, like previously mentioned 4997 Masquerade. Now you may be asking how we do CAD. Well, like previously mentioned, we do it through a computer application called Autodesk Inventor.
Autodesk Inventor is a computer-aided design application for 3D mechanical design, simulation, and documentation of parts and assemblies. Inventor allows us to design 3D models before assembling the robot. It is an efficient and accurate application that allows us to plan out and visualize how our robot can possibly turn out and function. Now, let's get into some basics of Inventor. To begin, press New at the top of the Start It menu. A window will pop up with different options. Here, we can create a new file, like a part file, an assembly file, a drawing file, or a presentation file. We could also choose what kind of units we will be using. I will be creating a standard inch part file. Press Create. The user interface is similar to that of Microsoft Office. The blank space that we see here is called the graphics window. To the left of it, we have the browser window, which provides information about the model. What we have on the very top is called the Quick Access Toolbar, which has some functions like Open, New, Save, and the Undo options. Just below the toolbar, we have the ribbon, which consists of tabs like the 3D model and Sketch and Annotate. Each tab consists of panels. These panels have more options and functions. The cube to the right is called the View Cube. It allows us to look at the part from different perspectives. Just below the View Cube, we have the Navigation panel. The Navigation panel lets us move more efficiently across the screen using these tools. To start a sketch, press on the Start 2D Sketch option. Choose one of the work planes to work on. Here we see some basic commands like line, circle, arc, rectangle. These can be used to draw the basic outline of your object. In this demonstration, I will be creating a cube. You could type in your dimensions. Now I will finish the sketch. Now since our sketch is complete, to make it a 3D object, we have to use the extrude command. The extrude command allows the feature to have depth. Press on the surface that has to be extruded. We could change how deep our object is going to be. Here we have the basic cube. Now you know how to make a basic part. Now that we have gone over some basics of CAD, let's start designing the robot and going over some of the commonly used features in Inventor. Let's go over some of the basic assembly constraints in Inventor. Assembly constraints define how parts relate to each other, and they also restrict the movement between parts. We could see there are 4 basic constraints here: the mate and flush, angle constraints, tangent constraints, and the insert constraint. This is the mate constraint. Mate allows 2 faces, edges, points, or axes to join. As you can see here, these 2 surfaces, after placing a mate constraint, they have now joined. Flush constrains 2 faces, edges, points, or work features together with geometry side by side. These 2 surfaces, shown right here, are facing different directions, but with the flush constraint, they are now facing the same direction. Angle constraint constrains 2 faces or edges at an angle to one another. As you can see right here, the top block is at a 45-degree angle compared to the bottom block. With an angle constraint, they are now aligned. The tangent constraint constrains a curved surface to a plane or another curved surface. The cylinder and square here are separated. With a tangent constraint, they are now joined. The insert constraint constrains a cylinder flush into a hole. The block and cylinder are separated. To have the cylinder insert into this hole, we can place an insert constraint. And now the cylinder fits perfectly inside the hole.
Now that we've gone over the different features in Inventor, we can take a look at how to get parts for assemblies. There are 2 ways to get parts for assemblies. One would be to go completely custom and create it in Inventor or a similar program. Typically, teams do this because it allows them more flexibility. Another way to get part files for assemblies would be to get them on commercial off-the-shelf websites. We can take a look at an example of this on GoBuilda's website. GoBuilda is a really popular FTC vendor for parts. So taking a look at the website and scrolling down, we can find the parts. So over here, we can take a look at something like the quad hub mount over here. We can see all the product information, and if we scroll down, we can see under downloads, there's a step file, which you can just click on and then it'll download. And after you've downloaded it, you can import this into Inventor and use it for any assembly you need to use it for. Now that we've gone over how to get part files, we can take a look at a demonstration of all these features and parts in the drivetrain and grabber. Okay, now we're here in Inventor. When you launch the application, you'll be greeted by this screen. And do not fear, this seems complicated at first, but it really isn't that complicated once you understand where everything is. So over here, we have new. So this is where you create a new assembly or part. And typically we create an assembly in FTC because we already have our parts. Over here, we have the projects, shortcuts, and file details. Typically, you'll only deal with these if you're creating new projects, and you can quickly launch them from right here. Down here, we have our recent documents. So this is everything that you've recently opened, all the parts and assemblies. And for reference, parts.ipt files typically are in step files when you get them from online vendors, but Inventor likes to work with IPT files. And that's the Inventor part file. and the inventor assembly file is IAM. And you can pin these if you use them a lot, so I could pin this, and it would be right here, easily accessible. So now what we want to do is we want to create a new assembly. So what you would do is you would go to File up here, New, and Assembly right here. Give it a minute to load, and it'll load up a new assembly that's completely blank for you to create your robot or what else you want to create in here. So you can see here a few basic navigation tools. So when you're up here, this is really similar to another program, Microsoft Office. Microsoft Office also has tabs like these, and this can make it much easier for beginners since most people are familiar with Microsoft Office, like Word, PowerPoint, Excel, and so it's a bit easier to understand. So when you create a new assembly, you want to import parts, and you can do that using this place button right here. So typically when you download them off of online, they'll be in step files, like right here. So what you want to do actually is you want to be opening these parts and converting them to IPT. I'll show you how to do that right now. So you go over here and you hit open. Once you're here, you want to change this to step files and then open up the step file. And it'll open up a new tab down here. You want to convert the model, so we can hit OK. Once it loads in, you'll see that the part is right here, and you can view it, you can pan around, you can rotate. But Inventor likes to use IPT files. So what would you do? Well, Inventor already did all the work for you. You can see down here it's IPT. So all we have to do is just close out of this, save changes, yes. It'll bring up a dialog menu, and it'll save it where you have the step file. And now you have an IPT file, and now you can use that to place it. So over here we have IPT. We just have to open it, place it down, and we just hit escape to exit the placing dialog. And voila, here we go. So we have the Rev expansion hub right here in our assembly. To zoom in and out, you would use the scroll wheel. And to rotate, you hold shift and you hold down the scroll wheel button, like click down on it, and you just move around. And to pan around, you just hold down the mouse button, the middle mouse button, and you can just pan around like that. And you also have the option to navigate up here. So you can just click right there. Up here, you can rotate it however you like. Works perfectly. So now we're going to be going to the drivetrain we created earlier. So we're going to close out of this, not change. We're not going to save changes. Okay, now we have the drivetrain. And this is the assembly for the drivetrain. And as you can see, there's a lot of parts here. But don't be scared. It's not as many as it seems. As you can see, this is really simple. The reason why there's so many parts is that there are a lot of screws in order to fasten it. So over here, you can see that we have the drivetrain, which is used to, like the name suggests, drive. And so these motors over here create power or torque to power these wheels and allow the robot to move. And typically a drivetrain is going to be more simpler than other parts because it just consists of the chassis, motors, and the wheels. So to put all these together, you obviously need to use different commands. And probably the most common command you'll use in assemblies is the constrain command up here, under relationships, under assemble. When you constrain, basically all you're doing is you're essentially constraining it. You're defining its behavior. So if we go up here to constrain, you can see here that you have many different options, but the two you'll probably use the most is the mate and insert constraint. Insert, like the name suggests, and also you can see the picture, is you would just insert things into other things. So over here, for example, we can look at the screw. So if you click on it, it'll highlight which part it is on the left. And you can expand this, and you can see all the constraints you have on it. So over here, we have the insert constraint to insert it into this hole. And so that's how this C channel right here mounts into this quad hub mount right here. You would also use the mate constraint for other things to put two things together. So, for example, let's take this C channel. So let's just copy and paste that. And then we'll also take this quad hub mount down here. And then we'll just paste this right here. So you have the quad hub mount here, and you want to attach it here like we have over here. So what you would do is you would go to constraint. The shortcut for it is C. You'd go to mate, and you would go right here, and you see that there's an arrow right here. And you won't want this always, but in this case, we want it like that. So we're going to constrain this big hole right here. So that we're going to click that. So we made the first selection here. Now we need to make the second selection. So what we want to do is we want this hole right here, and we're just going to click this. And as you can see, it mated, and we basically defined the behavior. And as you can see, you can move it around. So it means that it isn't perfectly constrained. And in order to do that, you would have to do two more constraints. One constraint would to make sure that it's flush with this face right here, and the other constraint is used to make sure that this hole aligns with this hole, and all the other holes align with other holes. So to do the flush constraint, sorry, my bad, you would actually do mate here. So you would go back to your constraint menu, and then you would mate this right here. So mate this to this. As you can see, if you hit apply, it's mated to this, and it won't go anywhere. It's stuck in place. And to make sure it actually won't go anywhere, like it won't rotate around, you would go back to your constraint menu. You would go over here. You would click on the threading inside the quad hub mount, and the hole right here, apply, and there you go. You have successfully constrained this, basically adjusted its behavior to attach to this. So wherever this C channel goes, this quad hub mount will go. And essentially that's what constraints are used for. Now, normally you would have a rev hub, like previously shown, to control everything. But for this demonstration, we're not really going to show that, as it's a little more complex and also requires some more explaining, which will be done in the electronics video on day 4. So now that we've gone over the constraints and basic controls, we'll be transitioning over to the grabber and talking about how constraints are used there and how that's used in this year's game.
I will now show a grabber inspired by Team Midnight, another Middleton community team. This grabber mainly consists of a servo, flat beams, and a U-bracket. We used 7x64 screws to fasten parts together. This is the servo block. The servo block gives the servo structure and a way to attach to the main piece. There is also supposed to be a servo horn here, which is similar in function to an axle. The servo horn transfers the power from the servo gear to the mechanism. To put together parts in CAD, we use constraints. Here, we used a make constraint. I mated the center axis to align with the hole, and then used a make constraint on the bottom of the screw to the top surface of this flat beam. The function of this mechanism is to bring blocks into possession of the robot. There's also another similar mechanism which allowed us to hook onto the foundation and bring it in and out of the depots.
Well, that's it for today. Thank you everyone for watching. Next up, we'll be building and parts. Hope you have a good day, and we'll see you tomorrow.